Okay guys, so in the previous video we learned about Euclidean division algorithm, that was A is equal to BQ plus R, where B is divisor and Q is quotient and R is remainder and A is dividend, the number that is being divided. In other words, we could write it as like such. We are getting a remainder of R, right? So today we are going to look at extended Euclidean algorithm, and we haven't really learned. We have in the upcoming lectures we will learn about GCD, but for now all you need to know about GCD is that it is the highest common factor. Highest common factor means the biggest number that divides both number. For example, if I ask you 12 and 8, what is the biggest number that divides both? 4 divides there, 4 divides there. This is the biggest number. If you go 5, 5 does not divide this. If you go 6, 6 does not divide that but divides that. So it must be dividing the both. So 4 divides both and is the biggest number that could divide both. That's HCF. Okay, so it is asking that GCD, find the GCD of this, and the only property of GCD that you need to know for now is GCD of A, B is same as GCD of B and R. B is a divisor and R is a remainder. So if I tell you that GCD 15 and 4, GCD of 15 and 4, GCD of 15 and 4, it would be same as 4 the 6, no, 4 3 the 12, okay, and then you get a remainder of 2. So I can say it is same as GCD of divisor, which is 4 and 3. Okay, so this property you need to know for extended Euclidean division algorithm. Okay, so it says 5 2 9 5 and 4 3 2 1. So 5 2 9 5 and 4 3 2 1. Now extended Euclidean algorithm says that you continuously divide and apply this property until you get a 0. Let me explain how. Like 5 2 9 5 and you divide it with 4 3 2 1 and 1 4 3 2 1, and then you get something like 9 7 4, right? Which means we could write it as, according to this Euclidean algorithm, we could write it as 4 3 2 1 into 1, because 1 is the quotient, and then you write the remainder, which is 9 7 4. And now again we're gonna find the, again we now move this quotient over here, 4 3 2 1, and our remainder becomes the divisor. You could look at here and see 9 7 4 would now divide 4 3 2 1, 4 3 2 1, and if you multiply it with 4 you get something like 9 7 4 and 9 7 4 into 4, 9 7 4 into 4 is 3 8 9 6, which gives you a remainder of 4 2 5. So you could write it as 4 plus 4 2 5, right? And then you bring 9 7 4 here, and our new divisor become 4 2 5. Just like 9 7 4 bring down 9 7 4, our new divisor becomes the remainder 4 2 5, and then you multiply it with 2, 4 2 5, 4 2 5 into 2 is 850, and then you get a remainder of 124. Okay, so multiply with 4 and you get a remainder of 124, and then you bring 425 becomes new number and divisor become our remainder. Okay, so like the previous, just look at it, the previous divisor becomes the number and the previous remainder becomes the divisor. That's what I'm saying. That's what I'm writing. What you see here on the right hand side, the left hand side is just it's a way of writing it in Euclidean algorithm. Okay, 124 becomes new divisor and you multiply it with 3, and then you will get a remainder of, I believe, 53. Okay, and then you bring 124. The previous divisor becomes the number, and the remainder becomes the new divisor. 53 into 2 gives you the remainder of 18. The previous divisor becomes the number. 53 becomes the number, and 18 into 2 becomes then that would give you a remainder of 17, and then previous divisor becomes the number, and 17 1 is 17. Okay, and then you get a remainder of, and then you get remainder of 1, and then the previous divisor becomes the number, and 1 into 17 has 0. Like if you go here, 18s divide 17s of 1, and then you get 1, and the previous comes here, and then it becomes this, and 17s are. So what this theorem tells us is that the moment you get 17, the previous remainder is GCD. That's what it is. That's what this extended Euclidean algorithm says. It says using this property, keep doing this continuously and until you reach the remainder 0, and before that the remainder that is before 0, that is the GCD. So I could say that GCD of 5295431 is 1. In other words, they are co-prime. Okay, in the next videos we will look at GCD, and we will look at properties and how to solve Olympiad questions. I looked at this topic. I just gave you the version of these questions because in the early stages of national contests, questions like